Artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello and welcome to episode 160. Today I am delighted to welcome back to the show Roman Yampolskiy. He was on in episodes 16 and 17, and that's far too long to go without talking again with him because he is such a force when it comes to educating people about the risks of AI in an intelligent and accessible way. He is a professor of computer science at the University of Louisville in Kentucky, where he is also the director of the Cybersecurity Laboratory. He has published so much in the field of AI safety for so long that he is largely responsible for the field having that term. He has written numerous books, including Artificial Superintelligence, a Futuristic Approach in 2015, and Artificial Intelligence Safety and Security in 2018. I'm grateful to Roman for many things, not least being listening to a complete newcomer and endorsing my first book in 2017, but especially for his philosophy of coming out of the ivory tower to educate and empower the average person to understand what the risks of AI are and taking a stand on the existential risks of AI, starting in a time when the only people doing so were in three categories: people who were on the fringe, people who didn't care about being seen as on the fringe, and people whose reputations were so unassailable that nothing they said could harm that. And as a professor of computer science, someone who teaches freaking C++, he could not be easily dismissed, and he forced academics and technologists to listen to him. He's done extensive research and writing on the core issues of future AI safety, like how we could control an artificial superintelligence or constrain its values to align with our own, or indeed whether such aspirations are even possible. And it's important to note that he's not just waxing eloquently on these matters like, say, myself, but as an academic, he's using formal methods to pursue precise conclusions with mathematical rigor. So understandably, the recent explosion of capability in AI and the even larger explosion in mainstream interest in AI has propelled him onto an elevated popular stage. And yet with all the interviews he's been giving, he didn't even hesitate to make time when I asked him to come back on the show. So let's get right into the interview with Roman Yampolskiy. Roman, welcome back to AI and You.
Thanks for bringing me back.
Well, I've seen so much of you in media these days, interviews with TV shows, traditional kind of format of male and female news anchors, asking you about AI control problem. I have to ask, does it feel like you're in... Actually, have you seen the movie Don't Look Up? And does it feel like you're in Leonardo DiCaprio's character?
I mentioned the movie in my interviews. I tell them this is exactly what the experience is like. I tell them, hey, it's going to kill everyone, and they ask me if it's going to take jobs or not.
So priorities. And a couple of years ago, would you have anticipated being mentioned in the same sentence as Leonardo DiCaprio?
No, but I've been compared to characters from other movies, so it's not completely novel.
Oh, which ones?
What was the bald guy, beautiful
was
robot?
Ex Machina?
Ex Machina. What is the name of the scientist?
I don't remember either, but I know the one you...
But I had a different haircut. It made more sense back then.
Yeah. So things have shifted radically in public conversations, obviously thanks to ChatGPT, but in particular with respect to talking about existential risk. A year ago, that was still fringe. Only two types of people talked about that. People who were on the fringe or didn't mind being seen on the fringe, and people whose reputation was so unassailable that there was no way that it could be damaged by talking about existential threat, like yourself. Now we have two public letters. We have had the call for a 6-month slowdown a pause in building models. And we've had the recent letter from, was it the AI Safety Institute? Remind me on that was saying this is...
AI Safety Research something. They're fairly novel, so I'm maybe not correctly remembering the name. We can look it up if needed. AI Safety Research Group, maybe?
Yeah, and I believe you signed both of those. So some of those surprised me for several reasons. Not that you signed them, not that the concern is there, but that several elements of how those came about, I think, are very interesting. Can you talk more about your perspective on these calls for slowing development and paying more attention, which obviously comport with your views, but how do you see that as having entered such a larger sphere of attention now?
So I think the main goal of those letters is to generate some attention, some publicity. I don't know if specifically asking for 6 months is that useful. We would want capabilities of some kind to be delivered, not a specific timeline, ability to better understand those systems, ability to control them perhaps before we start training the next model. So 6 months is not a relevant factor, but you're showing that there is thousands and thousands of good researchers in different companies, academia, who take this very seriously. The second letter was very short. It wasn't a letter, it was a sentence just saying, this is as dangerous as the worst thing we can think of, nuclear weapons, pandemics. This is not about algorithmic bias. This is not just technological unemployment. This is really serious.
Right. And what was really interesting about that is that the top names on the list were the people who are building the thing that's getting us closer to that as fast as possible. What do you think their motivation is in drawing that kind of attention to themselves? I mean, it's like, the CEO of Philip Morris saying smoking causes lung cancer. I mean, yes, but that's the last person we'd expect to admit it.
So there are some kind of speculation ideas about what's happening. They are in charge of for-profit corporations. They need to make money for investors. So they can decide unilaterally to stop doing what they're doing. They will lose any competitive edge they have. Whereas if government comes in and puts an upper limit on what can be done, they can still monetize their existing models, but they will not be outcompeted in that place. So it would benefit them financially, I think, to have some sort of a supervisory role for the government. And so saying that, yes, we are concerned about worst possible outcomes doesn't really take away from their business model and may actually benefit it.
Has that public statement and others like that increased the general level of alarm and fear with respect to AI? And is that happening in any useful sense?
Again, I think every time I give a talk, people tend to concentrate on aspects of AI which are not the main concern for people who wrote that letter or signed it. It's about algorithmic bias. Is it discriminating? Is it going to take my job? What about sex robots? Things of that nature. They very rarely concentrate on the big point. And I think it's some sort of a human bias. We kind of deny the fact that we're getting older and going to die soon, all of us. Always been, and we're not spending 100% of our personal or communal budget on fighting it. And it seems like we're kind of doing the same thing here globally. We as a humanity realize we may be getting to the end of our natural usefulness, but we are not doing anything about it.
So a lot of people are obviously encountering this issue for the first time, and Hollywood has done a lot of their thinking for them. So they gravitate towards scenarios like Skynet that we dismissed a long time ago. But that doesn't mean there isn't an existential threat. It's just in ways that they haven't contemplated before. You've done some more work recently on papers that you've published about the control problem. Can you familiarize us with that work?
Right. So we don't really agree on what the problem is, right? We have different names for it historically: computer ethics, friendly AI, control problem, alignment problem, safety of AI. But we all can understand what the problem is. We want very powerful systems, which we don't regret using. So what would it take to get there, to solve this problem? And it seems like we would need certain tools. We need to be able to understand how the AI works. So explain neural networks. We need to be able to predict some intermediate decisions they would make, their instrumental goals. We would need to be able to verify that the code matches design, and so on. You can kind of think about a dozen or so of different useful tools to have. And in my research, I try to understand, are those tools available to us? Maybe we can explain some parts of its design, but not all of it completely. What are the limits? What is the upper limit to human understanding? Obviously, there is some limit. It's different for different people, but even for the smartest humans, there is upper limit to what they can comprehend. Maybe humanity as a whole or scientific community can do a little better, but at any point, I think there are those limits, and I try to investigate them. I publish papers on those individual results, and we just recently got a survey of about 50 of them published in a very good journal, should be coming out shortly.
So when we're talking about existential risk, that phrase is an abstraction that no one can wrap their minds around without jumping to lots of conclusions that don't get us very far. But what seems to be missing a lot is a connection for how that actually could take place. There's a lot of hypotheses about things like paperclip maximizers, Stuart Russell's robot cooking the cat, but it seems that this isn't well fleshed out. Do you have a more complete scenario for us about how this might happen?
So I have a paper which explicitly says that we cannot predict what a more intelligent agent will do specifically. Mm-hmm. We can give examples of what we would do if we wanted to destroy humanity, nanobots, viruses. But by definition, if it's a super intelligent agent, we cannot know what it's going to do. Obviously, it's going to come up with something really novel and awesome to accomplish its goals. We don't control its goals. We don't control terminal or instrumental goals for that agent. So the best I can do is, what would Roman Yampolskiy do to accomplish this, but not what AI is going to do.
Granted, and one assumes that you don't deliberately spend a heck of a lot of time thinking about how to destroy the human race, so you might not be as good as the AI. But you use the word want to there, and there is a considerable risk from a system that doesn't have any desires at all, right?
So we believe there are some instrumental goals on which any intelligent agent will converge. It will try to acquire resources, preserve its own stability, whatever utility function it has. And those are already dangerous because that's essentially a survival instinct. And then we are a competing form of intelligence. We may be trying to disconnect it if we don't like something. So it may be beneficial to take us out.
Let's look at the large language models. ChatGPT has just been a watershed. There's before and there's after in terms of the public narrative and interest in artificial intelligence. And first of all, a year ago, when we were talking about the existential threat and these, again, sort of hypothetical terms about, let's imagine an artificial general intelligence scenario, values aren't aligned and so forth. And again, doing this hypothetical work, it's still hypothetical, but a lot of people are seeing it as being less hypothetical. How much closer are we to that kind of scenario? How much less theoretical is it now as a result of what large language models have done lately?
Well, of course, we don't know for sure, but if we kind of measure progress from GPT-2 to 3 to 4 and just kind of project the same level of progress forward, it seems we would hit human level and maybe beyond in about the same amount of time, 3 to 5 years.
You and I and others talked years ago about some of the progressions that we could see happening in AI and forecast things that were scenarios similar to what we have now with the capability of GPT-4 and its friends. But it still has surprised me in many ways. How did you react to that when it came out? Expected or unexpected? Where did it sit on that axis for you?
I surveyed people on social media before GPT-4 was released, trying to see what the community thinks it's going to be able to do. And they all kind of said, yeah, it's like GPT-3, but a little better, more. So we kind of expected, yeah, it can still program. Now it does a better job. Yeah, it can still write essays, but they make more sense. I'm more kind of surprised by how little anything in the world has changed as a result. So we have this thing which 20, 30 years ago, everyone would agree was general intelligence. We solved AI. It's amazing. But it made absolutely no difference for most people. That's kind of shocking, right?
Well, maybe we just take longer to react. I mean, in some circles, if I'm understanding what you're saying correctly, there has been a large reaction. The amount of code in Silicon Valley, the proportion that's being written by large language models at the moment seems to be huge and heading towards 100%. That's got to make a huge difference.
I don't know. I talked to some programmers and they kind of still working as before. Their bottlenecks are maybe data, if it's health applications. They're not specifically looking for just someone to produce a lot of lines of code. This is helpful for introduction to programming students, but less so for advanced programmers.
I think the thing that I'm still trying to come to terms with is I can understand its performance as essentially autocomplete. I can trace that back through things like Word to Vec. I can see the history through GPT-3. That made sense as a completion. When it got to the 3.5 models, that was then doing things that I didn't find the autocomplete model or explanation adequate. I'm not saying there's a different explanation. I'm saying it doesn't satisfy me. When I, for instance, given it a programming problem, it solved it by giving me the code, using the variables I gave it, the variable names, and putting them in the right places, which implies a lot more than the sort of what word would fit best next kind of model to me. I realize that's still more or less what's going on under the covers, but it shocks me that it can produce code that's not just syntactically correct, but semantically. What's your reaction?
It is impressive. It seems like it started to create internal models to better predict the next token. And some of those models allow it to understand chess or programming or specific subdomains. And as the neural network itself gets bigger, the sub-neural nets within it apparently scale as well and become more capable. At least that's my best guess about what's happening.
Are you ready to locate this somewhere within the vague boundaries of what we call artificial general intelligence?
So we classify it as how general it is and how intelligent?
Yeah.
It's definitely a proto-AGI. It is better than an average human in many domains. It is terrible in others. It is some sort of a autistic child, I guess, and we keep teaching it, and we discover that just asking questions in the right way makes it much more capable, much better. If we guide it, hold its hand, and give it examples, it learns to do things it couldn't do before. So it seems very similar. Like if you had, I don't know, maybe a genius 10-year-old with severe autism or something like that, that's pretty much what you're looking at.
And it's working by being essentially a genius at putting together tokens into language because it's been trained on so much language, but it doesn't nominally, out of the box, even have the concept of a fact, let alone truth or falsehood. So when it hallucinates, one of the mistakes that people make is thinking that that's a bug, and if the programmers just locate the code that's doing that, then it'll stop hallucinating. And I say, no, hallucinating is the only thing that it does. It's us that interprets its result as being either true or false. You're going to need a completely different system to audit that. What does that do for our future, given that hundreds of billions of dollars are being thrown at developing this kind of technology? It's going to go someplace really fast. And if this is the model that's going to take us there, where do you think that that's going to lead?
So they are connecting it to internet. They provided plugins such as Wolfram Alpha, which give it some computational ability to access data sets, check encyclopedias. So it may become better just checking its own output, kind of self-censoring. I don't see it as so different from what average people do, right? If you talk to an average human, we kind of live in bubbles of academia and such, but average humans, they have a lot of those hallucinations. So horoscope, it's very important for me to read my horoscope for next week. That's exactly what the system would do. It has completely incorrect understanding of a situation, but it talks about it. And there are many examples of humans doing this type of linguistic output as well.
I want to run a theory by you, something that occurred to me the other day that I have absolutely no reason or justification for, but it's a thought that occurred to me that seemed interesting. The model for large language models is that they give responses that are, by definition, by design, the most reasonable and aggregate average human response, right? It's based on their training. There's some random numbers thrown in there, but what makes them so believable is that they are trained on so much language that they look like exactly what a human would say, right? When we are considering the value alignment problem, the biggest challenge, perhaps there are several, is that we don't know what human values are. How are we supposed to know what to align with? I wonder whether you could say that to the extent that a large language model is trained on so much data of what humans have said that it looks to be the most plausible human-like output, could you say that its values are necessarily, by that principle, optimally aligned with humans?
There are problems where taking an average will not get you an aligned solution. So if you think about a hate group who wants to kill 100% of a minority group and someone else who loves them and doesn't want to kill any of them, so 0%, saying that aligned solution is to kill 50% of them is not really
right
what we're hoping to achieve. It's trained on a lot of data from what available data is, Western world, English language. So it definitely doesn't take into account 8 billion humans we have. And for once it does, it looks at science fiction, it looks at crazy forum posts, it looks at all sorts of data. No one should be training anything up.
Yes. And I just wonder, though, as a theoretical principle, could you say that if something was trained on enough human language, that it would derive from that an alignment with the values that were represented in that training data?
It might. It might become more and more like a typical human, which is a very dangerous, unsafe animal. You don't want an average human to be in charge of a world deciding important things. We see how it turns out, even with them being mortal and still human in a true sense. But a dictator make them immortal, more powerful, more intelligent. It will not be a good solution, I think, even if it's picking up some of those averaged preferences for temperature, for emotions, for whatever we care about.
I think it's interesting that I haven't seen as much argument as there could have been and as I expected to begin with about the political leanings of these models in their output, which of course is evident when you ask any kind of question that encroaches into that space, and that there could be groups that would start arguing, you're letting this thing loose and it's not representing us, even though they're way out on the fringe. Do you see more risk coming in that area, or have we somehow dodged that bullet?
Well, I think we had those conversations when it first came out, and I think Elon Musk pointed out in others, it was very similar to how Facebook or Twitter were. They were very pro-liberal, censoring conservatives, and conservatives called for creating, their own language models without liberal bias. So I think we did experience that.
You talked earlier about having a paper about the impossibility of, I think, proving that we could know how an artificial general intelligence works. Did I characterize that correctly?
So specifically for neural networks as the prototype model for creating intelligence, there are two things. We need to be able to understand what the explanation is, and the system has to somehow be able to generate that explanation. The only true explanation for how that model makes a decision is the model itself. If you get a copy of all the weights, you have a true explanation, but it's useless to you. You cannot comprehend it, billions of nodes, trillions of connections, and not very helpful. So then it has to do some lossy compression, trying to explain it to you. Maybe it will pick top 5 reasons decision was made. You are given that. So now you're getting only partial explanation, partial picture, which may be useful in some contexts, but it's not a full picture. And I think it's very similar to how we explain things to children. A lot of times we don't feel like going through the real answer, so we give them some complete lie or simplification. Where do babies come from? Oh, we bought you in a store. Okay, everyone's happy, you got an explanation, but it's not true, it's not useful, and as things get more complex, you'll get less and less of reality provided to you.
The sort of breakthrough that these models represent, it seems to be confined to language. We have had roughly an equivalent breakthrough in the image generation models, which again are doing things that I didn't think should be possible from what they were doing a couple of years ago, because at that point they were generating images that looked like a Salvador Dali painting. They undeniably gave you the feeling of what you had asked for, but they didn't represent anything in reality. That I could understand, but now they're generating things that have correct perspective, object size, lighting, connections, and so that we had a breakthrough there in image generation. But aside from that and language, I think the big field that hasn't advanced as significantly is robotics and getting an understanding of the real world. Do you think that there's anything equivalent waiting for us in that field, that we might see a leap ahead?
I would be surprised if it didn't happen. If we just took an existing humanoid robot, something from Boston Robotics, let's say, and put in a large language model with all its vision and language capabilities, I think it would very well manipulate a robot and be able to follow instructions. I think there is some examples of doing it with hand manipulation and other controllers. So I think it's actually very multimodal. It's not just text and images. I think those same models are able to create novel molecules, design all sorts of architectural, mechanical things. So it's impressive, definitely.
You're right. I'd forgotten that GPT-4 is multimodal because my version still isn't, but it's doing that for other people. Do you think that if we throw enough compute and parameters and training data at a large language model, that we will get to AGI?
I think it's worse. I think we train it for so long, let's say 6 months, we don't even realize we passed that level. We can get to superintelligence right away in the first run because we don't monitor the run. We need time to test it once it is fully trained. So while we're training it, maybe after 2 months it hits human level, 3 months is superintelligent, and we keep training it. We don't know that yet.
One thing that hasn't been mentioned in a while, and he brought up Ex Machina, which mentions the Turing test, but ever since then, it's faded from view. The Loebner Prize stopped running, and it's as though it's no longer useful, which I think is probably the case anyway. What sort of tests should we apply? Is there a test that we could apply to an artificial intelligence to decide that there's something on the inside, or that there is, it's hard to define this. There are words like self-awareness, consciousness, sentience, all bracket this. What do you think?
I was not aware that they stopped running Loebner Prize. I'm kind of surprised. It seems like this is their time to shine and really be on TV doing this live. I still think Turing test is very legitimate. If you can fool a specially expert for a long time, then it's hard to claim you're not equally intelligent. So I would not require some other specific test for showing human level equivalence. Now, if you want generality beyond human generality, you can come up with tests for mathematics and things of that nature, but it's not as easy for us to generate since we don't understand those domains outside of human expertise. We're general within the context of what humans care about. We're not universal intelligences. So I'm not sure much more is needed. I would just be happy with it passing an existing Turing test.
Do you draw a distinction, or do you think there's a distinction worth drawing between something that is conscious or self-aware and something that produces a convincing imitation of that?
So the internal states, qualia, are extremely important for the agent in terms of suffering, in terms of rights. So that's what determines this aspect of it. In terms of safety, I couldn't care less if a thing is conscious or not, is equally dangerous just based on intelligence and capability.
That's the end of the first half of the interview. It's certainly not going to come as a shock that this one was long enough to need to be split across 2 episodes. I think it's really interesting that people are now thinking about new models for human language and cognition to explain how ChatGPT is producing some of its results. The Turing test refers to the proposal by Alan Turing, back in the early 1950s no less, that we should hold a blind competition of human judges talking to other humans and computer programs via text chat, and if the judges can't tell the difference, the programs should be considered to be performing human thinking. For several years, the Loebner Prize was an actual instantiation of that was run at the University of Exeter in the UK. You can Google for Loebner Prize, that's Loebner, and see its history, and no, I don't know why it's no longer running at a time that I expect that a bot would finally win it by any standard. In today's news, ripped from the headlines about AI, a breakthrough discovery at the University of Limerick in Ireland has revealed for the first time that unconventional brain-like computing at the tiniest scale of atoms and molecules is possible. And I want you to know that it took a huge amount of self-restraint on my part not to insert an actual limerick on the topic at this point, especially given how easy it is to get ChatGPT to come up with them now. The team, led by Damian Thompson, professor of molecular modeling, developed a 2-nanometer thick layer of molecules that can remember its history as electrons pass through it. 2 nanometers, that's pretty thin. Thompson said that, quote, "The switching probability and the values of the on-off states continually change in the molecular material, which provides a disruptive new alternative to conventional silicon-based digital switches that can only ever be on or off." End quote. Their research, published in the journal Nature Materials, has the delicious title of Dynamic Molecular Switches with Hysteretic Negative Differential Conductance Emulating Synaptic Behavior, and explains that this enables the molecular switch to emulate Pavlovian learning. That may ring a bell with you. They conclude by saying that this research, quote, opens up a new way to design junctions that emulate brain-like features, end quote. Next week, we'll conclude the interview with Roman Yampolskiy when we'll talk about wider-ranging issues of AI safety and just how the existential risk is being addressed today. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.